Okay, so this is a look at what we're going to be making here in this video. Actually, this will probably be a series of either 2 or 3 videos, depending on the length and how much detail I go into with them. Here you can see projectiles moving towards a quad, and there's a shader that we'll be writing in these videos to accumulate the impacts, and you'll be able to adjust the colors. So over here you'll see some of the settings that you're able to set, so you can go in and say set the color for the different impact areas to different values. You can tell it to pulse, you can give different strength and diameter values, all kinds of little settings you can set up. So that's where we're headed, and we'll see how long it takes to get there. Alright, so we should start out with getting a empty Unity project. You can start it up. This is Unity 2020.110F1, but I'm pretty sure this will work in any version of Unity all the way down before 2018, because the shader code and things I'm going to be doing haven't changed in a very long time. But so the first thing to do is to create a 3D object of a quad and bring it in close. We're gonna get there, then we're gonna set its position. Let's set it somewhere we can easily see 0, 0, 0. Set it to 0, 0, 0. Then we're gonna give it a scale of 2, 2, 2. Alright. Now we will I have a texture that's a prototype texture. I'm gonna drag onto it. You can download one from the internet or use whatever texture you care to. It's basically a background texture. We're going to be putting a shader on top of the texture, so you'll see through it. We'll use alpha channel to see through to the texture behind it. This is a prototype texture, a free texture download from Unity store. Okay, so we have the quad. So the next thing we want to do is create a 3D object, a little sphere, and we're going to make it 0.05, 0.05, 0.05 in scale, basically 5 centimeters. We're going to put it at a position of 0, 0, and -1 on the z-axis. So now we have a projectile. We'll call it projectile, and we'll call the quad target. Okay, so the quad comes in with a mesh collider. Mesh colliders are required in this because mesh colliders are the only way of getting texture coordinates back on collisions. If you use a box collider or some other kind of collider, you will not be able to get your texture coordinates back. Now on our projectile, we're going to add a component, a rigid body, and we'll make sure that gravity is turned off, but other than that we'll leave it exactly like it is. And now we'll create some scripts. So out here in assets, we'll go right click, create script, and we're going to call this quad script, and we'll create another one. Once it's done, create C# script, and we'll call it projectile script. Okay, so we will then drag them onto their respective objects, put the quad script on the quad, click on the little sphere, and put the projectile script on the projectile. Double click on the projectile script and open it up in Visual Studio. And in here, we're just going to do something super simple. All the projectile script's job is to go forward at a constant rate. So we're going to say transform position equals transform position plus new vector 3, 0, 0, 1 times time dot delta time. Okay, so what this does is basically moves that projectile straight down the z-axis at basically 1 meter per second. So let's have a look and see how that looks. So we should be able to enable this. And we see it go on down right through the quad and keep on going. Okay, good. Next step is to go over to our quad script, and we'll work on some code here. Alright, we're going to do onCollisionEnter. And this is called whenever a rigid body runs into our collider. Basically, whenever the projectile script, the sphere, hits the quad, this is going to get called with some collision info. Basically, in this collision object is a list of contacts for what's contacted that frame. So we're going to loop through all of those. So let's do for each contact point in collision. Okay, so that will loop through, making CP equal to each contact one at a time. We're going to go ahead and debug log out. Each contact has in it an other collider, which is the other thing that collided with it. And so we're going to log out what that was. And one other thing we're going to do real quick here is destroy object, other collider, game object. So what this will do is log out when our projectile hits, it will log it out and destroy it. So basically clean up the world. So when we hit play now, we should see the sphere head in. We get a message saying contact with object projectile, and we see it has disappeared from the scene because it was destroyed. Okay, so we are detecting collisions. Now we want to get the rest of the information that we need. Going back to our quad script, we need to create some rays. The problem that you have with onCollision, this collision gives you a world point, a point in the world that the collision took place. But we don't really want a point in the world. What we really want in order for our shader to work is we want a position in the texture, the material that's been applied to this. So if you can imagine this prototype texture that I have on here is 512 pixels by 512 pixels, but it's on a 2 by 2 world object. But this world object, this quad, could be 20 by 20. It could be 100 by 100. And the same texture would be spread over 100 by 100. What we really want to get is when our projectile hits, we don't want to know the world coordinate. We want to know the texture coordinate, the offset in the texture of where it hit, because that's what we're going to have our shader draw into. Now the problem is that collision does not give the texture coordinate. It gives the 3D world coordinate. So what we need to do is cast a ray, a physics ray cast, from the collision point a little off of the quad. We'll come up off the quad a little bit. Okay, so when this comes down and hits, when it hits like right there, right, it'll give us that point that it contacted at. So what we're going to do is we're going to come back off the normal. The normal is a point that points directly off the surface. So we'll take the point and we'll add the normal. We'll subtract the normal for it, because the normals always face the direction of the z-axis, and see blue is going that way. So we're going to actually subtract the normal from it, and that will give us a point out here. And then we're going to cast a ray in the direction of the normal, which is this blue arrow, towards the quad, and it will give us a contact point, a hit point, and that hit point will have a texture offset in it, which is what we will need to pass to our shader. Okay, so let's do that. Alright, so here we are here, so we're going to create a vector 3 start of ray, and we're going to go from CP point, that's the point of contact from the sphere with our quad, and we're going to subtract from it because it's right on the surface of the quad right now. We really want to be away from the quad a little bit, so we're going to subtract from it the normal. The normal is a direction that aims directly off of the surface, right? So we're subtracting the normal from the quad. The quad's very thin. The normal is a unit vector, so it's 1 meter basically. So we're basically backing a whole meter away from the quad, a little far. But that'll be the start of our ray, and then we need a direction. And that's just going to be raydir. That's just going to be the normal. Okay, so just to review one more time here. The normal points the way the blue axis is. Our point is here. We subtracted the normal from this point, which moved us back to about here, well, wherever 1 meter is away. And then we set that point as the ray start, and we told it to go in the direction of the normal. Now that's the blue direction, the z-axis. So it's going to go this way. And so we're going to go out here and cast a ray this direction. Okay. So we've got our ray direction. So now all we have to do is make a ray. Ray equals new ray, and all it needs is the start and a direction. And now we do a physics raycast. It returns a bool if it hits something. We're assuming it's going to hit something because we've kind of carefully moved away from something we know it's going to hit. Equals. And what it needs is it needs the ray. It will send out a hit point. Oh, we need to give it a hit. We need to create a hit point actually. Okay, so it's going to give back a hit point in the hit variable we just created. And now we need to give it a distance to go. We're going to tell it to go 10 meters. We know that we're only a meter away, so 10 is going to be fine. It'll stop when it hits it, so it won't matter. And then we're going to give it a layer mask of what it's going to run into. And we'll call that. Okay, so it's going to look for an object called with a layer of heat map layer. Now, right now, our quad does not have that. Okay, right now its layer is default. And so I've added before a heat map layer. And if you needed to add it again, you'd come in here to add layers and pick a layer, any available one, and type in heat map layer. Then click on your object, and it'll be available in the pull down heat map layer. So now we now have our ray, and hopefully we have a hit object come out, and so we'll test to see if we hit it. If hit it, and if we did, we're going to log out some info. So here we have the collider object and game object name. So we're going to print out what it hit, and we're going to print out the texture coordinates. Hit dot. Let's see, it gives texture coordinates. There we go. We're going to print out the X and Y texture coordinates. So let's see how that runs. Okay, now we're right down the middle, so we really should see a 0.5, 0.5. Oops. Yeah, I need to move the sphere. Whoops. I need to move the sphere, the projectile back off. I had hand moved it back in, so let's back it off. And press play. There it goes. Bam. Okay, and here we have hit texture coordinates 0.5, 0.5. Now, texture coordinates go from 0, 0 to 1, 1, and we were dead center, so that's 0.5, 0.5, so that's correct. Okay, so now we have collisions with our object working from our projectile. The next step that we need to do is we're destroying this. Alright, so let's create a shader material. So over here in your assets, right click, say create, and you'll see shader, and do an unlit shader. And we're going to call this Heatmap Shader. And it opens up, well, it didn't open up, let's see. Let's double click on it, and it will bring it up in Visual Studio. And you can see there's a bunch of boilerplate. Basically, Unity fills in and comes in with a default shader that basically just makes everything white. You can see the word white here. So if we come in here and click on our quad, and you'll see it says shader is standard right now, we can actually do the pull down, go to unlit, and we'll see the one we just made, Heatmap Shader. We'll add that. Okay, and so now that shader is in effect. And the way we can test to see how that's in effect is we can come into our, oops, where is this? Hold on a sec. Come into our Heatmap shader. If we come down here, let's get rid of some of this boilerplate. We don't need fog. You can see that basically all this does is it gets color from the texture, the main texture, and returns it. So it pretty much doesn't do much, but we can change that. We can say color equals fixed for 1001. Now this is red, green, blue, and opacity or transparency. So this basically will turn the color all red with no transparency. So you see it's all red now, because basically it set every pixel. This shader routine, this fragment part, gets called for every pixel across the quad. So it will call this with a different location in the UV, and this IUV will be different. So this gets called, in this case, 512 by 512 times to get a color for every single pixel across there. In this case, we set it all to red. So what we're going to want to do now is to set up some variables in here. So we're going to do most of our work in the fragment shader here. So we'll set up some variables that are required to get this to work. We're going to need a few. We're going to need some a color array. So that's a float. Make it a float 4 of colors, and we'll have 5 of those. And we're going to need to have some point ranges. 5 of those. Now these are tied together. The point ranges are going to be what we look up the weight of our collision, the points when we have a collision in, and then we look up what color to display there in the color array. This will be clear in a little bit. We're going to need a couple of inputs that we get from the script, that the script will pass in. It's going to need to pass in some points, so we'll make a float underscore hits. Now every point is going to have an x coordinate, a y coordinate, and we're going to have another one called the intensity, so a third float. So it's going to have 3, and we're going to allow for 32 points. So 3 times 32 is the number of floats in this array. Okay, and then we're going to have an integer called hit count. And so basically the script is going to set hit count it's going to populate the array with the x, y, and intensity for as many points as it wants. Then it'll set the number of points in hit count. And then when the fragment shader runs, it will know how many points are stored in this array and can loop through them, which we're about to do now. Okay, So every time this is called, it's called for every pixel. Let's go ahead and get rid of this red setting here. We want to set up a UV range that's a little bit larger than what was there. So we're going to say float2 UV equals I.UV. That gets the UV coordinate into a local variable. And then we want to say UV equals UV times 4 minus float2 of 2, 2. Okay. Okay. So what this does is the UVs come in from 0 to 1 with 0.5, 0.5 in the middle. This is basically going to change that to be between -2 and +2 in the x and -2 and +2 in the y, with 0, 0 being in the dead center. This just gives us a little bit more range to work with and makes it easier. So now we are going to need to initialize some of these variables that we've put in up here. So let's create an initialization routine. Just call it init. Okay, so init is going to set up, we need to set up our color ranges. So like the colors are going to range from black basically, or transparent, all the way up to red. So we're going to want it to slowly increase, say from black to green to yellow to orange to red, right? Now we'll make these settable and variable in the material editor probably in another video, but for now I'm just going to initialize them to some values here. So let's say we do colors 0 equals I think it's float4. Yeah, float4. Yeah, it's going to be a float4. 1, 2, 3, 4. Black, basically. Colors 1 equals. Hang on, let me. I have a cheat sheet to the side here. I'm looking these up. So 0, 0.9 for green and 0.2 for blue, and then you can see it. And then colors 1 equals float4. We're going to give it a lot of red, comma 1 for green, 0.3 for blue, 1 for transparent. Colors of 3 equals float4 of 0.9, little less green, little less blue, slowly becoming oranger, and then finally the last one is going to be full red. Full red, not transparent. So there's our colors. We'll set those up so that you can change them later. The next thing we need to do is we need to set up our point ranges. Now the point ranges are going to be pretty simple. They're just going to basically step by 0.25. So let's see, point ranges 0 equals 0. Point ranges equals 0.25. Point ranges 2 equals 0.50. I could do this in a loop, but I'm going to be able to set them in passed-in variables later. Ranges of 3 equals 0.75, and then finally 4 equals 1.0. Okay, so there's our point ranges. All this will make sense in a little bit, but we have to have those initialized. So when our fragment shader comes in, we're going to call init. That will initialize those variables. We get our UVs, and we're ready to do our looping now. Now, what we're going to have to do is we are getting hit count points passed in, and so let's go ahead and actually hard code a hit so we don't have to pass one out. Let's say hit count equals 1. This is just for testing. These will get passed in, but for now we're just going to do it. We're going to say hits 0, which is the x coordinate of our first one, equals 0, and hits sub 1 equals 0. That's the y coordinate. I'm going to say hits of 2, which is the intensity, equals 2. All right, so we hard-coded one point, and we're basically at the dead center, and a little bit of intensity. All right, so what we want to do is we want to loop through all of the hits, and for this point, this UV coordinate, we want to sum up the distance away that that point is from this UV, and if it's far enough away, don't do anything, but if it's really close, give it more and more and more weight to bring it so that the color will get redder and redder. Okay, so the way to do that is we're going to have a total weight started at 0, but then we're going to go for a for loop, I through hit count. Okay, so we're looping through every hit. We've hard-coded 1, so this will obviously only happen once the first time, but that's fine. But now we want to get the work point from there, so we're going to create a local variable here, float2 work point float2, and we're going to get it from the hits sub I times 3. And I'll talk about this in a second, comma hits sub I times 3 plus 1. All right, and then we'll multiply it by underscore hits sub I times 3 plus 2. You may want to look at that for a second, make sure you understand what's going on. Because in the hit array is one big array, every 3 of them is 1 point. So we're going through all the hits and we're offsetting by multiplying by 3. We're jumping to that point. And the first one, plus 0, this has a plus 0 in it, I could have put plus 0 here, is x, plus 1 here, see, plus 1 is y, and plus 2 is the intensity. And the times 3 just jumps us forward. So as we go through the hits, number 2 would be 6, and then this would be 6 plus 1 or 7, 6 plus 2 is 8. Right, so we're basically extracting the work point from there. Actually, I don't want to put the intensity in here. I just want to get the point, and we'll do float point intensity equals I times 3 plus 2. Just to store it in different variables so we have it for some future math stuff. Now, we want to add total weight E8 plus equals, so we're going to add it to it. Now, we're basically going to take 0.5 and we're going to multiply it by the distance. So we're going to write a function. We're going to have to write a function that takes the distance squared. So let's say we say dist squared of UV, our UV coordinate, and our work point. Okay, oops, work underscore point. Then we're going to multiply it by the intensity. So now we have to write this distance squared value. Alright, so let's go up here. And we're going to go float. It's going to return a float. It's going to take 2 float 2's, A to B. And basically A is the UV coordinate. Here we are. A is our UV. B is our work point. And we basically want to get the distance away. Now I want the return value here to be between 0 and 1. So we're going to have to do a little work to get that to happen, but it shouldn't be too bad. What we'll do is we're going to say float D equals 1 minus, now the shader language has a built-in distance function, which is kind of convenient. Okay, so what this does is, if you remember, we've changed our UVs to be -2 to 2, which is 4 by 4, right? So here we're saying if the distance is more than 1, this will turn negative. So we want to actually let me just write this out. We'll go d equals the max of 0.0 comma that. All right. So what's this saying is, if the distance is, say the distance is 2, that 1 minus 2 is a negative number. So this will return 0, basically. So if the distance gets greater than 1, this is going to return 0, meaning it's not going to have any effect on our total weight. This is going to return 0 multiplied by 0 multiplied by 0.5, all becomes 0. So it adds nothing. Now 1 is 25% of a 4 by 4 grid. If we have a grid that's 4 units by 4 units, 1 unit by 1 unit is 25% of the grid. So this actually is just restricting the influence of a point to not being any greater than 25% of the texture. 25% is kind of a lot. Now we're going to take the we're going to square this to keep it positive. I mean, right now I don't know that it can go negative with that max in there, but what we're effectively doing is raising the power and dividing by the new power with the 0.5 out there. Okay, so with this we now have, if the distance, say the distance is equal, so it would be 1 minus 0, it'll return 1 because that's the max. If the distance is far away, greater than 1, it'll return 0. So it's going to return a value between 0 and 1. Now we're going to want a little fudge factor in here. So let's do I'm going to make it 1 right now, and we're going to stick this in here, and what it's going to do is allow us to change the area of effect. Divide by area of okay, so like I said, this is going to affect 25% of the texture. Now that may not be a good thing. We are very likely to want it to be, instead of 25%, to be 5% of the texture, or 10%, depending on circumstances, or the size of the object. If it's a BB gun versus a baseball versus a softball versus a basketball, the area of effect, you may want it to be bigger or smaller. So we're throwing this in here, we're setting it to 1, we're dividing this by 1, and which basically does nothing because 1 doesn't do anything, but we can change it to influence the area, the diameter. Kind of is like the diameter of the affected area. I'll show you later. It'll become very obvious what it does later. Okay, so now we're going to return D. Okay, and I think everything's good. So total weight 0.5 times that. So we're summing over our loop here, and once we have all that, we want to return our base color, which is our color from our texture, but we want to add in a float 4, and this float 4 is going to be well, now we have, well, yeah, we're not quite ready for this, are we? All right, so now we have a weight. Now a weight, these weights are going to be what is in these point ranges. So this weight is going to be 0 to 1, right? Actually, it's going to be very likely to be over 1, or but it's going to come in, and these point ranges, when it falls between or over one of these point ranges, if it's say 10%, 0.1, it should return a color between 0 and 1. So if the weight is between point range 0 and 1, it should return a color between 0 and 1. So we need to write a routine to get the heat value from the for that pixel from the weight. So let's do that. Okay, so it's going to return a color, so it'll return a float 3. Get heat for pixel, and then we're going to take in a weight. Okay, now we'll do a few bounds checks that are real simple here. We'll go if weight is less than or equal to point ranges sub 0, then return color sub 0. So if it's negative or below point ranges. Point ranges doesn't have to be 0. We have it set to 0 right now, but you may choose in the future to change it. So we're actually checking if it's lower than that. If weight is greater than or equal to point ranges of 4, maximum 1, then we're going to return the maximum color. Okay, so anything that's basically that's going to be full red. So if the range, if it's above 1.0, it's going to return the range, the full red. Okay, so now we've got to figure out when the weight is somewhere in between the two extremes. So we're going to loop through. And we're going to start at, not at 0, at 1, because we've already done 0. I'm going to stay less than 5. And we're going to go if the weight is less than point ranges sub I. Okay, if we found a spot where where the weight is less than the next point range, then we need to get the distance from the lower one. So let's see, we'll go float dist from lower point equals weight minus point ranges sub I minus 1. So this will get how far the weight is into that point range below it, right? Now minus 1 here is safe because we started at a 1 with the I loop, so this is guaranteed that at worst it'll be 1 minus 1 or a 0. And then we need to get the range size. So we're going to go float size of point range equals point ranges of I minus point ranges of I minus 1. So this gets the size of the range, because it could be anything. You can adjust them so that we don't know what the sizes are. And then we want to get a ratio. We're going to get this divided by this, and it's going to give us the ratio of them. So float ratio of lower point equals dist from lower point divided by size of point range. Now I'm making these variables super long just because this is a demo and an example for people trying to help you understand what's going on. But basically what's going to happen is this value is it's sort of like a percentage into that the weight is above this point range below it. It's going to be a value between 0 and 1 that we're going to use to move into the color space now. So we'll go and offset that from the color. So first we need to get our color range. Float 3 is equal to the colors of I minus colors of I minus 1. So that gets the range of the color range that matches the range here, right? And now we want to multiply by this ratio to get our color offset. It's sort of like a lerp. So we're going to say float 3 color contribution equals color range times ratio for lower point. Okay, so that gives us a color contribution of the weight into the range that it was, but now we need to add in the base range. So we're going to say float 3 new color equals colors sub I minus 1 plus color contribution. Did I spell that right? I hope so. And then we return a new color. Okay, you should look through that, make sure you understand it. It's pretty simple really, but it can seem complicated at first. Okay, then there's a case here where you're going to have to return colors sub 0. The compiler hates it when you leave a potential exit point without a return value. It's a bug. All right, so let's see where we are. So we're going to say float 3 heat equals, what did I call this function? Get heat for pixel of the total weight. And then we're going to take the base color of the texture that was there, and we're going to add in a float 4 of heat, comma 0.5. which is going to let us see through. This is basically the three colors, red, green, and blue from Get Heat Pixel, and then we're adding the fourth transparency value here so that we can kind of see through it. Now I'm sure there's a ton of bugs in this thing. So let's go. I called init, right? Let's see what see how bad it hates it. Yeah, it hates it. Undeclared identifier hit count at line 68. It looks like I spelled it wrong. Line 68. Yeah, hit count needs a C, capital C. Oh, there we go. Oh, and look at that. So here, this is our predefined one. It's at 0, 0, and we can see it has a little bit of red in there. And look, you can see on a 4x4 grid, it's taking up one section. So it is taking up a larger area. Now let's go over to the code again, and let's try playing with some values. So let's say I give it an intensity of 4. See what happens. Now you see the red has gotten bigger, and these other ones are. But notice that the diameter, it still takes up the exact 2x2 amount. Okay, this is 25% of this 4x4. It's taking up, you know, basically 4 squares, or 25%, like I had said. Where, whoops, sorry. Where's our distance calculation? Here, this 1 is 25% of a 4x4, right? And I said area of effect size. So let's say we make an area of effect size 0.5. 0.5. Now let's go see what happens. Here's my Unity. There we go. See, it shrunk it down. Now it's brought it into half that. So now it's literally 1/8, or 1. Yeah. So you get it. It's 1 cube now. So you can adjust sort of the diameter of effect by adjusting that value. Okay. So now let's go back to here. Let me put that back at, I guess we'll leave it at 1 for now. Put in a value we can change later. Okay, I think that might be a good stopping point for this video. We're 42 minutes in. So if you get this far and you get it to the point where you can see and adjust those values, the next video we're going to have this start moving. We'll set up some parameters to pass in to our shader and get some values passed in and allow you to change some colors and that kind of stuff. Okay, if you like this, please hit the like button. Thanks, guys.